Our second formula that we get to discuss today is at the beginning of section 2, which is called our midpoint formula. Given 2 points, a segment connecting those 2 points will have a midpoint with this location. What this says in English is you take the x-coordinates, add them together, divide by 2. That's just taking the average of the x-coordinates. What this says in English, y1 plus y2 divided by 2, means take the 2 y-coordinates of your 2 points, add them together, divided by 2, which means just take their average. Let's put this into play. Let's find the midpoint for all of these. Add together the x's, divide by 2. 1 and 5 make 6, divided by 2 is 3. 5 plus 2 makes 7. 7 divided by 2 is 3.5. So the midpoint between these 2 points would be the point 3 and 3.5. It's okay to use decimals. Sometimes we can't avoid it. 10 plus negative 5 is positive 5. Positive 5 divided by 2 is 2.5. Average the y-coordinates. 29 divided by 2 is 14.5. The midpoint of a segment containing these endpoints would be 2.5, 14.5. Let's keep going. Add these together. Negative 1 divided by 2 is negative 1/2. Add these together. Negative 24 divided by 2 is negative 12. Add together and divide by 2. Negative 19 divided by 2 is negative 9.5. Negative 30 plus negative 29 is negative 59. Divided by 2 is negative 29.5. Add together 9 divided by 2, 4.5. Add together 4 divided by 2 is positive 2. Add together 21 divided by 2, 10.5. Add together 29 divided by 2, 14.5. Add together 5 divided by 2 is 2.5. Add together 28 divided by 2 is 14. Last one, add together negative 6 divided by 2, negative 3. Add together 28 divided by 2, 14. These are the midpoints of segments with these following endpoints. Okay, what do we do with this? In our next section, we get to apply this skill much like we applied our distance formula to determine how to classify triangles based on their side lengths. The directions say, what is the equation for a perpendicular bisegment for each of these segments? Let me reread that. We want to find the equation for a perpendicular bisector of a line segment with these following endpoints. Well, I need to describe to you what a perpendicular bisector actually is. A perpendicular bisector does 2 things. It is perpendicular to the segment that is given. It also cuts the segment into 2 halves, which means it has to pass through the midpoint. So a perpendicular bisector of a segment passes through our midpoint, and it also is perpendicular to the given segment. Just as a refresher, since we're talking about perpendicular, what we're going to do is find slopes. And then in order to have a perpendicular bisector, a perpendicular slope, we're going to find the opposite reciprocal of the given slope. So perpendicular bisectors cut a segment in half and runs perpendicular to the original segment. First, number 17, let's find that midpoint. The midpoint. Add these together, divide by 2. Negative 1 and 3 make 2. Added together, divided by 2 makes 1. Positive 6 and 4 make 10. Divided by 2 is 5. So we know that the bisector passes through this midpoint. If it's perpendicular bisector, then it will be perpendicular to the slope of AB. So I'm going to write, what is the m of AB? What is the slope of segment AB? The change in y divided by the change in x. This y goes down 2 units. When the x goes up 4 units, the original slope is negative 1/2, meaning the perpendicular slope of AB would be the opposite reciprocal, positive 2/1. Now we're going to find the equation for a perpendicular bisector is the equation for a line. I have 2 different formulas that I could use. I could use point slope This is our point-slope formula, or slope-intercept form. I'm going to try to demonstrate both to you today. First, I guess we'll start with our point-slope. I want the line to contain this point and pass through this point and contain a slope of 2. Y minus the y-coordinate equals 2 times x minus the x-coordinate. This is a perfectly acceptable point-slope formula for a perpendicular bisector. It passes through the point positive 1 and positive 5. Some of you may want to continue working on this and simplify it. If I bring over the 5 to the other side, now it's of a formula that looks and reminds me of vertex form. Positive 1, positive 5 shifts the graph 1 unit right and 5 units up. It's linear because there's no exponent here. If I continue to evaluate this formula will transform itself into our slope-intercept formula. Y equals 2x plus 3. Either a point-slope formula or slope-intercept formula would be a correct answer. Our next exercise, we want to find the perpendicular bisector of CD. First, we need to find the midpoint and the original slope of CD. The midpoint, add these together, add the x coordinates together and divide by 2. Our midpoint, positive 2 divided by 2 is 1. Positive 2 divided by 2 is 1. The midpoint of this line segment CD is 1, 1. The slope of CD, change in y. This y-coordinate goes down 6 when the x-coordinate goes up 4. Simplify this to become negative 3 over 2. So the perpendicular slope of CD will be the opposite reciprocal, or 2/3. I'm going to use our point-slope formula one more time. Y minus the y-coordinate equals our slope, and x minus the x-coordinate. That's our point-slope formula. Sometimes it might be easier to rewrite this into slope-intercept form by distributing and moving this one to the other side, so let's do that. Also, I wanted to remind myself, the reason I'm using the perpendicular slope and not the original slope is I wanted the line that I create to be perpendicular to the original. I don't want it to have the same slope or else it would be parallel. Let's see, I was in the process of moving this one by adding it to both sides, distributing my 2/3. Now wait a second, 2/3 plus 1. Well, I'm going to convert my 1 into 3/3. This way we have equal denominators and I can combine. This is the equation of our perpendicular bisector in slope-intercept form. Here's our last one. You can pause it and see if you can try it out yourself. If not, I'm just going to keep going. I'll give you a second to pause it. And we're back. Let's find the midpoint. Add these together, divide by 2. Add the y-coordinates together and divide by 2. Here's the slope of EF. The y-coordinate goes down 2. The x-coordinate goes up 6. Our perpendicular slope of EF would be positive 3. I'm just going to show you what if I just start with point-slope form, and not start with point-slope form and do slope-intercept form. I can use the old y equals mx plus b formula to start. I can plug in my slope, the perpendicular slope, and one of these coordinates and find the new y-intercept. 5 equals 6 plus what number? Minusing 6 from both sides gives us our y-intercept. Last thing I need to do is rewrite our formula with the slope we found that's perpendicular and the correct y-intercept. This way I know it's going to pass through this point. If I plug in 5, I get 15, but I take away 1. Now wait a second, if I take away 1, I get 14. That's not this. You know what I did wrong? I used the endpoint. I should have used the midpoint. Mistakes happen, and that's why I self-evaluate. Let's try this again. Let's use our midpoint this time. The y-coordinate, the slope, the x-coordinate of the midpoint. Let's find the y-intercept. 4 equals 15 plus b, minusing 15 gives us our y-intercept. Let's see if this one works. So y equals 3x minus 11. Plug in the midpoint because this line has to pass through the midpoint, not either endpoint. Plug in 5, I get 15, take away 11 makes 4. There we go. Glad I checked. Our last video is on next.